Hello and welcome to our data science channel. The aim of this channel is to understand difficult problems by solving actual examples. So the first question in this series belongs to a series of 7 good probability questions. And the first question is that we are tossing a coin 4 times, provided that at least 2 heads occur within those tossings, and the probability is to be found that at least one tail also occurred. So 4 times you are tossing the coin, so H, 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 T. So this kind of sample space can be created, which is depicted here. There can be 16 such sample cases, and the probability of A is defined as probability of at least one tail, which is 15 by 16. As you can see from here, because H, 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 H is excluded from the 16 outcomes in the sample space, and the probability that at least 2 heads are there is 11 out of 16 out here, and the probability of A intersection B is given by you can directly look at the sample space that both these conditions are satisfied, that there is at least one tail and at least 2 heads. There are 10 such cases in the sample space. Otherwise, you can use this particular formula, probability of A multiplied by probability of B given A. So probability of A we have already found out, 15 by 16, and probability of B given A, the conditional probability formula is with us. So given A, that is at least one tail is there. So 11 cases out of out of that are such that where you have 11 by 15 are the cases where you have at least 2 heads, given that you have got at least one tail. So there are total 15 cases at least one tail, out of which 11 are having at least one at least 2 heads. So you got probability of A intersection. Now you apply the Bayes theorem. Bayes theorem is as highlighted in the blue here. Probability of A given B is equal to probability of A intersection B divided by probability of B. So we have all the values with us, we plug them and we get the answer 10 by 11. Second question is also simple. It says 2 fair dice are rolled simultaneously. Find the conditional probability of event both dice get equal values, provided that the sum of the values on dice is less than 6. Let me repeat. Find the conditional probability of event of both dice getting a doublet. You are getting a doublet here, provided that the sum of the doublet is less than 6. So the sample space of rolling 2 fair dice is always 36, as depicted here, right? 1 1 1 2 1 3 1 6 2 1 2 2 6 3 1 2 3 6 and 4 1 2 4 6 and 6. So there are 36 possible outcomes when we are rolling 2 dice. Now getting a doublet, the probability of A will be 6 such outcomes, 1 1 2 2 3 3 4 4 5 5 6 6, and the probability of getting a doublet is total number of favorable outcomes divided by possible outcomes, which becomes 1 by 6. Now in addition to that, you've got a doublet and you want the sum to be less than or equal to 5, because then only it is less than 6 if it is less than or equal to 5. So now let that probability be equal to some event of getting sum less than or equal to 5. Now, if you see here, the number whose sum will be less than 1 in the entire sample space are 10 such cases, right? So therefore, the probability of getting sum less than 6 is 10 by 36 or 5 by 18. Now, what is the probability of intersection of both these two? That you have a doublet as well as you have sum less than 6. So which is given by so the entire sample space is 36, and there are 2 only such cases, which are when you have the sum less than, in case of a doublet, the sum is less than 6, only 2 such cases, 1 1 2 2, right? Rest all are greater than 6. So there is 2 by 36 or 1 by 18. Now you apply the Bayes formula to it and you get probability of A intersection B divided by probability of B. So what you have to keep in mind while applying the Bayes theorem, as we are doing here, is that this is the base formula to be applied, and uh, most of the time you have to think over the numerator term. So you can think of the numerator term as the favorable outcome in the entire sample space, and then you can, you know, very well understand what's happening in your problem. Another way to do this exercise, another way to think of this numerator here is you can think of something like you want to find out probability of A intersection B, and that will be, if you go by the conditional probability formula, that will become probability of A multiplied by probability of B uh, given A, right? So this way also you can get the same value 1 by 18, right? Because you already know probability of A is you just got it up there, probability of A, and probability of B, that is sum less than 6 in given A, so that is also given. So you can multiply both of them, because one was 1 by 6 if I remember, and another was 1 by 6, and probability of B in that given A is nothing but 2 by 6. So when you do 1 by 6 and 2 by 6, it becomes 2 by 36, right? So this is another way of understanding the numerator part of the uh, numerator part of the Bayes theorem. The third problem is again a very straightforward one. A coin is tossed until it gives either 10 heads or 10 tails. Player A bets on 10 heads and player B bets on 10 tails. Okay, you are tossing a coin continuously until it gives 10 heads or 10 tails, and player A is winning if he gets 10 heads first, or if player B gets 10 tails first, he wins. So game is continuing till 15 such tossings, and we got 8 heads and 7 tails, but then the game was interrupted. Now you have to decide upon whatever you have got so far and distribute the prize money. Now how will you distribute the prize given whatever has happened? So let us draw a sample space for, you know, continuous tosses, right? So now what we have done is we have done uh, 15 tosses, and suppose we are doing 4 more tosses, right? 4 more tosses, because that will likely decide the case, because there are already 8 heads and 7 tails. So if you do 4 more tosses, definitely it will be, you know, one of the case where you will be getting either 10 heads done, or you will be getting 10 tails done. So one of them will get it finally in next 4 outcomes. And if you are doing coin toss 4 times, so what is your sample space? This is given by this table out here, and then there are 4 by 4, that is 16 such. We have seen it in earlier example also, 4 times tossing a case, and there are 16 such cases, right? Now the probability of winning of A is equal to the probability of getting 2 heads in any of the next 4 tosses, right? So in any of the next 4 tosses, the probability of winning of A, because he has already got 8 heads, now you get 2 more heads and you win. For the B, he has to get 3 tails in any of the next 4 tosses and he wins. So these yellow are the cases where, you know, if yellow happens, then A is not going to win, because 1 head 3 tail, 1 head 3 tail, or all 4 tails are highlighted in the yellow. So this is a probability that A will not win, and we get 5 such cases in the entire sample space. So the winning probability is high for A, which is 11 by 16, because he just needs 2 T's, which is all the green outcomes in the sample space here. Now probability of B, the yellow outcomes, which is 5 by 16. So how will you split? I mean, it's pretty simple now. So you split the prize money into the ratio of probability of A divided by probability of B, right? Which is 11 by 50. Fine. Next question. In a blackjack, there are 52 cards deck, 4 suits of 13, the normal 52 card deck, and digits are counted at their face value. Aces count for 11 and pictures count for 10. Okay. So player with maximum total value of cards is going to win, right? But the value should not exceed 21. Right. So now there are two players. One player is say, let us name him Alex. Alex has two picture cards. So he has already got two picture, means 20 points with him. And player B, let us call him player B. Player B has just one card, and that is an ace. That means his value is 11 now. What is the, and there's next card to be drawn. Player B is going to get it. What is the probability that player B is going to win? Right. So player uh, B already has 11 points. He should get a picture so that it becomes 21, or he can get a number 10 to win. So there are 12 pictures in the deck. Two are already with, say, let us name this guy Alex. Two are already with Alex. So the winning cards that are remaining is 12 minus 2, that is 10, plus 4 number 10. So there are 14 such cards already with him. So now how many cards are actually available in the pack? Because 3 are with the players, 2 with